Hello everyone. Today we would like to introduce a new and exciting feature that we have just released for version 46.0 of Spatial Work. This feature is called the Historical Viewer, and it has been requested by quite a number of our members. We've kept it in beta mode, but for this new version, it is fully tested, functional, and stable, which is why we have decided to release it. The purpose of this feature is to allow users who have historical data to play back that data, observe behaviors, and gain spatial insights over a specific period of time. Instead of just looking at instant results, users can trace back to what happened in the past. In general, there are different types of historical data. There is data related to object movement. For example, imagine you are running an autonomous warehouse with many MRs. For those who aren't familiar, AMR stands for Autonomous Mobile Robots. All the AMRs are tracked, and you can use the historical viewer to trace them based on where they were during the entire process. You can even take the historical data of the robot's movement and use the tool to play it back as often as you wish. On the one hand, for dynamic data, it is quite straightforward. You can use this historical data to review positions. On the other hand, there is the static sensor data. For example, if you have a temperature sensor in the room or a humidity sensor, you may want to understand how the temperature has changed over the past 8 hours. You can use the historical viewer to play back and trace all the data readings based on the available period you have captured. Now, let me demonstrate the functions of these two scenarios. Let's start with a dynamic object. A dynamic object, as we all know, is one that moves through space. A classic example of a dynamic object would be a robot. The data for a robot typically includes timestamps, with each timestamp representing different moments in time for the same robot. Then you have position and rotation data, along with other data such as battery level, wireless quality, and signal quality. If you are running AMRs, you can extract all of this data from a general database or an other source. This forms the foundation of dynamic data. For the purpose of today's demonstration, we have already imported a data API into the project, and it is linked to the project. It is called Dynamic Historical Data. Next, let's click on the icon called Dynamic Object. When I click on the icon, you'll see the dynamic object's data source appear, which has already been used to represent the robot's position. So far, this is a standard setup for dynamic objects. Next, let's apply the historical viewer to this object. To do this, first, I'll go to Viewer mode. In the viewer, select the historical viewer function. It is located on the left-hand side panel. Then, you will notice a panel appear on the right-hand side. Next, choose the robot's historical dynamic data source that is relevant to you. Then, in the Start Time section, enter a specific date and time. If you only need the available period, enter something random, and it will auto-correct. However, if you already know the exact time period, select it manually. For example, for us we will enter something random for now. You can either use the drop-down or type it in directly. Once you input all the information, simply press Process and the system will automatically correct the input based on the available period for this data source and adjust the relevant fields. Now, you can see the movement and the spaghetti maps when enabled. By the way, the spaghetti map helps to generate the movement trajectory if needed. You can choose to turn it on or off. In this 4-minute period, we can observe a few robots moving. Feel free to play it back and move the timeline to see where the robot has been, or click on the play button directly. Now let's explore static objects. For static objects, the first step is to create a static object group within the planner mode. Ensure that the static objects are properly mapped in the environment. For example, if you have 10 temperature sensors, you first need to create objects that represent those sensors. It is important to place these objects accurately in space based on their actual locations. That's what we did. We have a sensor group that includes a list of sensors, each represented by an icon. The position of these icons corresponds to the real locations of all the sensors. Currently, we can see that in the project scene, these are just 3D objects without any data linked to them. You need to ensure that you have a dataset formatted like this, which includes the sensor or object name, timestamp, and parameter readings. This is a standard format, and you can transform your data into this format. If you're unsure how to do so, an automated data handler may be available in the near future to assist with the transformation. We suggest you to subscribe to our LinkedIn group so you do not miss the launch announcement. Please be mindful that this format requires each object to have a unique name. You will also need to include a date and time, as this is historical data. We can adapt to a variety of standard date-time formats and perform automatic conversions. As you can see, This data includes a list of sensors, likely around 10 to 12. In Spatial Work, static data is designed to monitor groups of objects rather than individual ones. Therefore, it is not yet possible to create a heat map by selecting a single model. You must create a group, place your model within it, and ensure the model is correctly named according to the data source. Typically, the data source will correspond to the sensor name, so the sensor name must match exactly. Since this object is based on a 3D model, it has a .glb extension when imported. However, we can either leave the extension or remove it, and both will work. For this tutorial, I removed the extension for convenience to keep everything tidy and seamless. To activate the historical view, we already have the sensor, but now we want to read some sensors using the heat map feature. We recommend you to watch the tutorial titled Spatial Heat Map to learn more about this topic if you haven't already. For a general heat map, first select your group from the right-hand side panel, then click the Spatial Heat Map icon located on the left-hand side while still in planner mode. Then, on the right of the screen, a panel will open on the right-hand side where you can give it a name. We will call ours Humidity Cam Heat Map. Next, choose the data source that is relevant to you, as demonstrated earlier, and set some variations in the minimum and maximum box under the Process button, such as a range from 50 to 90. Now, let's process the query. Once it's processed, the parameters will be captured automatically, and the system will generate several options for us to choose from. We can select humidity as the base option, the 2D one, and the temperature value as optional. After that, we can save the heat map. The heat map is now saved, so let's move on to the viewer. In the viewer mode, we'll start by going to the Spatial Heat Map section. Click on the Spatial Heat Map icon, then go to the panel that loads on the right-hand side. Next, let's load the humidity heat map under where it says Heat Map. Now that it's loaded, you can see some of the data points are already visible. If you want to make the data stand out more, you can adjust the radius within the Spatial Heat Map panel, or the height, though that is not really necessary in this example. This is how the final frame of the Spatial Heat Map looks like. Now I am going to show you how to use the Historical Viewer feature, so we can review what data has changed over time. To do this, while in Viewer mode, go to the left of the screen and press the Historical button icon. Next, on the right-hand side, under Data Source, select the same data source used to generate the heat map. Then input the values that are relevant to you in the start and end time sections of the panel. Once you have put in the information, click on the Process button to process the data. The system will automatically correct the format. We now have the historical player that appears on the screen. Let's scroll through it to observe the changes. We can see that we're getting a good perspective. Now, let's click on the play button to see the sequence more clearly. As you can see, as we drag the timeline, the readings from all the data sources begin to generate the heat map. For static data, the heat map is tied to sensor readings, not object position, so it changes based on time. This approach doesn't work for dynamic objects, where the heat map reflects accumulated motion behavior. For static objects, the heat map represents the specific reading at each moment in time. You can use the Historical Viewer alongside the Spatial Heat Map feature to effectively visualize static object heat maps. This tool helps you gain deeper insights into the data. I hope this tutorial provides you with a clear understanding of how to use the Historical Viewer for both dynamic and static objects. Remember to join our LinkedIn group and YouTube channel so you are notified as soon as new features and updates are announced. Thank you for watching. See you in another video shortly.